Hello, curious minds. What if we told you that Mars once had oceans, a thick atmosphere, and maybe even life, just like Earth? So, how does a planet go from blue to barren? And could the same thing happen to us? Billions of years ago, Mars wasn't the dry, red desert we see today. It was warmer, wetter, and strangely familiar. Scientists believe Mars had a thick atmosphere, clouds, rainfall, and even rivers, lakes, and possibly vast oceans. Volcanoes reshaped the landscape, and a magnetic field protected the planet from harsh solar radiation, just like Earth's does today. Some researchers even think life, at least microbial life, may have had a chance to begin. But how do we know that? Well, Mars has ancient river valleys, dry lake beds, and even signs of deltas, places where water once flowed and pooled. Minerals that only form in liquid water have been found in the Martian soil. NASA's rovers have even detected organic molecules, the basic building blocks of life. And we know Mars once had a thick atmosphere because the surface shows signs of erosion by wind and water. In many ways, Mars was an early twin to Earth. But that resemblance didn't last. So what went wrong? The answer lies deep beneath the surface, in Mars' core. On Earth, our spinning molten iron core generates a magnetic field. It's called the dynamo effect, and it acts like an invisible shield, protecting our planet from solar radiation. Mars once had a dynamo too, but it didn't last. Why? Mars is smaller than Earth. Its interior cooled faster, and the molten motion that powered its magnetic field came to a stop. Without that movement, the magnetic field collapsed. This invisible shield was critical. Without it, Mars became vulnerable. But the real damage came next. When Mars lost its magnetic field, it lost its invisible shield against the sun's harmful solar wind, a stream of charged particles constantly blasting the planet. Without that magnetic protection, charged particles from the solar wind could slam directly into Mars's atmosphere, gradually blowing it away into space, molecule by molecule. Over millions of years, the thick, warm atmosphere that once surrounded Mars thinned to just a faint whisper. Now here's why that matters for water. Earth's atmosphere presses down on its surface, creating air pressure that keeps water stable as a liquid. Mars's thinning atmosphere meant this pressure dropped dramatically. With less pressure, liquid water couldn't stay on the surface. It would quickly evaporate, turning into vapor and drifting off into space. Meanwhile, colder temperatures caused the remaining water to freeze underground or at the poles. And because Mars lost its atmosphere's greenhouse effect, the planet's temperature dropped drastically. So not only was water disappearing, but Mars became a frozen desert, cold, dry, and barren. Today, Mars is a shadow of its former self, a cold, barren world with no magnetic shield, a thin atmosphere, and frozen water locked at the poles. Without internal heat to drive plate tectonics or volcanoes, Mars is geologically quiet, a planet that's essentially dead inside. But it still holds surprises. Scientists measured how fast seismic waves travel through Mars, and from that, they identified what materials lie beneath the surface. As Professor Michael Manga from UC Berkeley explains, this is the same technique we use on Earth to prospect for water, oil, and gas. The data revealed reservoirs of liquid water trapped 10 to 20 kilometers or 6 to 12 miles below the surface. This means Mars might not be entirely lifeless. Beneath its frozen exterior, liquid water may still flow. Mars is a ghost planet, frozen on the outside but whispering secrets from below. Mars' story is a chilling reminder of how fragile planetary environments can be. Earth's magnetic field and thick atmosphere protect us today. But billions of years from now, things will change. Eventually the sun will expand into a red giant, likely engulfing or sterilizing Earth. Before that, if our core's molten motions ever slow down or stop, our magnetic shield could weaken, leaving Earth vulnerable to atmospheric loss, much like Mars. While that distant future is far away, studying Mars reminds us how critical it is to understand and protect the delicate balance that keeps our planet alive today. Thanks for joining us on this journey. Here's a question for you. If a planet once so full of potential could change so drastically, what does that say about our own future? Let us know what you think in the comments. And if you're hungry for more space stories, don't forget to like, subscribe, and hit that notification bell to keep exploring with us. Thanks for watching. Until next time, keep looking up.